In this video, we will learn about how to create and use the analysis line. One of CIM's biggest advantages is that you can use models created in CIM to create civil analysis models without any additional work. However, among the objects modeled in CIM, only objects created as 1D members and 2D members can be created as analysis models. So, objects with irregular shapes created using the 3D CAD function in CIM or models imported from other programs cannot be created as analysis models. The function developed to solve this problem is the analysis line function. Now let's look at the analysis line function one by one, using the superstructure of a PSC beam bridge as an example. Please note that as the bridge on the screen is a model created using the 3D CAD function, it is currently not possible to create an analysis model. The analysis line function can be found in the Analysis group, in the Model tab of the ribbon menu. Analysis line creation options are divided into single element and multiple elements. The difference between the two options is that, in the case of single element, it is a function to create an analysis line consisting of one element, which consists of only the starting and ending point cross sections. On the other hand, multiple elements allows you to create an analysis line that is divided into multiple elements by setting the cross section at the user's desired location. In the example model, a cross beam with no change in cross section is used as a single element, while multiple elements are used for girders that require distinct cross-sectional variation. First, let's create the analysis line of the crossbeam using the single element function. The target object can be concrete or steel. For steel objects, you can add stiffeners to the analysis line. When creating the analysis model, section properties are calculated taking into account the stiffeners selected. In Property Reference, select the object to reference property information. In Select Member, you can make multiple selections by choosing the specific object for which the cross-section of the analysis line is to be obtained. Please note that Property Reference does not necessarily have to match Select Member, because it only references property information. Once the target selection is completed, define the path that will serve as the location of the element in the analysis line. There are two types of path: by draw, which draws directly, and by select, which selects the edge. Path definition can be done using any convenient method depending on the situation, but by using the by select option, you can make multiple selections, allowing for efficient creation of analysis lines all at once. On the second tab, you can access detailed settings for obtaining the cross-section. The tapered section option enables the creation of analysis lines with varying starting and ending cross-sections. The sectioning boundary option allows you to set the area from which sections are obtained. And in sectioning offset, you can set the position to obtain the section by entering a value. The cross-section of the analysis line is obtained based on the starting and ending point of the defined path, and its position can be modified through sectioning offset as needed. In the case of the crossbeam, it was initially impossible to create because the object is shorter than the defined path. However, by adjusting the cross-section acquisition position using sectioning offset, it becomes possible to create an analysis line. Once the creation of the analysis line is completed, you can verify whether it was created or not in analysis mode. Next is multiple elements. Select target is identical to single elements. Let's select the property reference and target member as girders. Define path is mostly the same as single element. But multiple elements, which can be divided into multiple elements, are provided with additional features in Define Path for ease of creation. In the By Draw method, you can define a path with a polyline. The By Select method includes an Edge Auto Tracking option. Edge Auto Tracking is a function that automatically locates a path by scanning edges linked to a particular edge when that specific edge is chosen. By using this option, you can define a path with one click, instead of selecting each edge one by one when defining a path. Next is sectioning points. In sectioning points, set the location where you want to obtain a cross-section from the selected objects. Clicking the Manual button activates a sub-panel where you can input sectioning points. Just input the location where you wish to obtain the cross-section in the sub-panel table. The starting and ending points of sectioning points are determined by the path defined in the previous step. There are two ways to enter sectioning points. One is direct setting. And the other is arrangement. The automatic button on the left side of the manual option is a function that automatically inputs the position to obtain the cross-section, by considering the position where the cross-section of the target object changes. Using this, you can easily define sectioning points without any additional work. The positions defined in this way can be checked by clicking the Manual button. As the second tab has identical options to the single element, a detailed explanation will be skipped. However, for girders unlike crossbeams, the tapered cross-section must be considered, so we will enable the tapered section option and create an analysis line. Now that the analysis line creation for the superstructure of the PSC beam bridge has been completed, let's create an analysis case and check the analysis model results in MIDAS CIM. To confirm, I will set the mesh size of the element to 1 division. As you can see, the analysis model has been generated according to each setting defined during the creation of the analysis line. Finally, here are some precautions. Firstly, the analysis line is a feature that can select member objects. Therefore, if the object is a body object, it will not be selected as the target object. Please change it to a member object before use. Secondly, to assign the analysis line created in library mode to the parent mode, it must be defined as a point-linked entity. Analysis line, like any other object, will not be assigned to the parent mode unless it is properly defined. So in this video we have learned about creating and using analysis lines. Thank you.